In this video, we will discuss how to solve titration math. Now, titration math is going to help you figure out the concentration of an unknown solution, which is determined in lab once you reach the equivalence point. If you've set up your lab correctly, the equivalence point may basically says that if it's set up correctly, the moles of acid and the moles of base are in their stoichiometry ratio. This ratio is generally 1 to 1, but it doesn't have to be. And so what we can do is we've got this really helpful equation here, which is MAVA divided by NA equals MBVB divided by NB. And NA is the coefficient of acid, where NB is specifically the coefficient of base. And then MA is the molarity of your acid. And then MB is also the molarity of your base. And then VA is volume of your acid. And VA and VB need to be in the same unit for the math to work out. Okay, so let's go through some titration math. In this first example, it says what volume of 0.2 molar sodium hydroxide is required to titrate 25 milliliters of 0.833 molar acetic acid to the equivalence point. And so once I see that we're talking about titrations and the equivalence point, I'm going to say MAVA over NA equals MBVB over NB. And let's see what I can plug in. I've got 0.833 molar acetic acid, so this is 0.833 molar. I've got 25 milliliters of that. And then the coefficient of my acid is just 1, so I'll put that in the denominator. That equals the molarity of my base, which is 0.2. The volume of my base, that's what I'm solving for, so that's just VB. And then the coefficient of my base is 1. And so my denominators really check out here that I don't have to do too much math with it. So I'm going to take 0.833 times 25, and then I'll divide over 0.2. And the volume of base that I solve for is 104.125. I'm just going to say 104. And it's got to be milliliters because VA is in milliliters, therefore VB needs to be in milliliters. Okay, now here in question number 2, it says consider the following acid-base reaction. We have this simple reaction, acid-base reaction, and it says what volume of 0.125 molar HNO3 in milliliters is required to completely titrate 37 milliliters of 9 molar barium hydroxide. So because we're doing a titration, I'm going to say MAVA over NA equals MBVB over NB. The molarity of my acid is 0.125 molar. The volume of my acid, that is what I'm solving for. I knew that this was my acid because it starts with an H, generally acids do. And the coefficient of my acid, Na, is just 2. That equals MBVB divided by NB. The molarity of my base is 9. The volume of my base is 37. And the coefficient of my base is 1. So what I'm going to end up doing is take 9 times 37. I get 333. I'll multiply it by 2 or cross multiply, then divide by 0.125. And when I do this, VA is 5,328. It says to solve for it in milliliters, and since VB was in milliliters, I know that that is correct. In question number 3 is very different, and so I want to walk through it just to see how this can work out. We want to know what volume of 0.812 molar HCl is required to titrate 1.33 grams of sodium hydroxide dissolved in excess water. And so I'm going to go ahead and say MAVA over NA equals MBVB over NB. And the molarity of my acid is 0.812 molar. the volume of my acid, that is what we're trying to solve for. And then the coefficient of my acid is 1. The molarity of my base is unknown. The volume of my base is unknown. And the coefficient of my base is known, that's 1. Well, if I think of molarity equals moles divided by liters, and I take liters times molarities, that gives me moles. And so what MbVb is trying to tell you is moles of base. So what I can do is I can go ahead and I can say I have 1.33 grams of sodium hydroxide. The molar mass of sodium hydroxide is 40.00 grams of NaOH for every 1 mole of NaOH. If I take 1.33 divided by 40, I get 0.03325. So I can plug that number in. When I solve for this, though, because I took molarity times liters, my volume of my acid will solve out to be in liters. So what I need to do is I need to take 0.03325 divided by 0.812, and my volume of acid is 0.0409 liters, which, since they say specifically for milliliters, that would be 40.9 milliliters. Okay, now here we have a 15 milliliter sample of HCl. It's titrated with 42.5 milliliters of 0.025 or 0.250 molar sodium hydroxide, and we want to know the concentration. So this is going to be MAVA equals MBVB, and divide each by NA and then NB. And I can automatically see, if I write out the double replacement reaction HCl plus NaOH, that I'm going to get NaCl plus HOH, and so all the coefficients will be 1. So I can plug in what I know. We have, we want to know the concentration, so that's Ma. We've got 15 milliliters of HCl. The coefficient of HCl was 1. That equals a molarity, 0.250 molar, times 42.5 milliliters, divided by the coefficient, which is 1. So 0.25 times 42.5 divided by 15. And the molarity of my acid is 0.708 molar. Okay, last one here. We've got 0.150 molar potassium hydroxide. It is titrating 20 milliliters of HCN. And we don't know the concentration of HCN. But when we titrate it, it takes 13.8 milliliters of base. That's the volume of the base. We want to know the concentration of HCN. So what we can do is MABA over NA equals MBVB over NB. If I write out my reaction, just a simple double replacement reaction, KOH plus HCN. When I do that, I get HOH plus KCN, and I can see that everything balances out. So Na and NB are both 1. The molarity of my acid, that is unknown. The volume of my acid was 20 milliliters. The coefficient of my acid was 1. The molarity of my base was 0.150. The volume of my base was 13.8 milliliters. And the coefficient of my base was 1. So if I take 1.15 times 13.8 divided by 20, when I solve for Ma, I get 0.1035 molar as my final answer.